Welcome back. This is video number 9 in my series on how to design a Telecaster in Fusion 360. In this episode, we'll review the toolpaths to cut a Telecaster neck on a CNC machine. So if you haven't seen the earlier videos, I suggest you check those out first. Just click on the info button in the upper right corner to get there. And if you have any questions, please leave them in the comments. I will get back with you. If you like the video, give it a thumbs up. If you want to see more videos like this, please press the subscribe button. Thank you. So we're starting in the manufacturer workspace. And in the last episode, we did this fretboard top tool pathing. I've added 3 more setups here. And let's review those new setups. So if I click here, I'm activating the setup. This is showing basically just a piece of stock with 2 index holes that are centered in the stock and 1 inch in from each side. So that's its own setup, basically just to drill these index holes. Then we get into 2 more complicated setups where we're finishing off the headstock portion of the neck and doing the truss rod. And I believe I did the tuner holes on this side as well. And then we're going to do the neck bottom, which is going to finish this curvature part of the neck and the transitions to the headstock and heel. So pretty straightforward. Let's start with the index setup. So if I double click on that, we're going to edit it. And I'll basically go over the setup here. So my stock box point in all of these setups is going to be the same. It's going to be the top of the stock and this point closest to me on my CNC. My long axis on my CNC is X and the short axis is Y. So I've configured my work coordinate system to match that. And what we're modeling here in this is basically just a piece of stock. So what I did was I went into my model, and here's a copy of the model, and I made a cam component. And inside that cam component, I made a neck stock component, and basically just made a 30 by 4 by 3/4 inch piece block, and that's this body right here. So when I'm selecting a model, what I'm modeling in this setup is just that piece of stock. And so if we go back to the design side, I can show you, let's see, if we activate our cam, I'm going to activate the neck. I think I've got another sketch on right here, which is probably the scale. So I'm going to hide that. And basically all I did was I made a sketch inside here to put these 2 holes in. So the holes are 3/8 of an inch because I use 3/8 of an inch wooden dowels, and I use a 1/4 inch bit to bore these out. So since this is a 4-inch wide piece of stock, all I did was I came in 2 inches with a dimension here and 1 inch from the end and my 3/8 inch hole, and then extruded that from the sketch, and that's basically what we're using for the stock. So when we go back into the manufacturing side, in this neck index setup, you'll see that what I picked here was this body, which is inside my neck stock component, and that's going to be what we're going to model in this very quick setup. The stock here, I'm actually using the same body for the stock. So I pick from solid, which means you're actually picking it out of the model, and then I pick this same body. So you can see here it's 30 inches long, it's 4 inches wide, and it's 3/4 of an inch thick. Okay, so basically all we need to do, let me collapse this model down. All we need to do within this setup is a single toolpath. So let's go ahead and look at this toolpath. This is a boring toolpath. I set my feed rate to 40 inches a minute, which I think is plenty. It's a 3/8 inch hole, so I need a bit smaller than that. So I'm using a 1/4 inch flat end mill. The geometry selection, if I turn this off and I can reselect it, I'm just selecting the faces of this hole, like so. So you see the two faces here. This is kind of cool here too. If I only selected a single face right here, then I can turn on this check mark right here, and it says select same diameter. It's going to automatically select the same diameter holes. So I've got a single face selected, but it looks for other holes of the same size. So if you had a bunch of holes, that's a nice little time saver. So the heights, basically our top height, which is our cutting height, is going to be the top of the stock. The bottom height, which is going to be the bottom of the cut, is going to be the stock bottom. But I want to go a little bit farther, so I went negative 5 thousandths. So basically this blue bottom goes a tiny bit beyond our stock, cutting into the spoil board a little bit, purposely, so that we cut all the way through it. Passes, I don't think I did anything here in the passes, and I didn't do anything in linking. So let's do an OK, and then we will simulate this toolpath, and it's probably on pretty fast here. Let me slow it down a little bit. Okay, so see, now you can see it boring down through this hole. And if we get a side view right here, you should be able to see the tool extend just a tiny bit beyond the stock. I'll pick up the pace here a little bit. Oops. Let's go. I didn't see it. Maybe you did. Let's let it go to the other side. I'll pick up the pace a little bit. Here's the other hole. And yeah, it did actually bore a little bit through. That's the remainder of the tool path, the tail of the tool path going through the stock. So that's it. That's all that's in the first setup. So now that the stock has these two holes drilled in it, I would position this on a separate spoil board, just a piece of MDF that also has the exact same two holes, and then put my wooden dowels in. So this is going to fix this position on the CNC, and then when we flip it, it'll also be perfectly centered. And that's why with this center holes, we want to use a work coordinate system that is centered on the stock. Okay, so I'm going to go to the next setup, which is the neck top. I'm going to activate that setup and hide the index hole toolpath. And you can see that we're using the same work coordinate system. So we're going to touch off the top of the stock for our Z. And you can also see our dowels in the stock and the neck model inside the stock. So let's go ahead and open this up. And you can see there's 3, 4, 5, 6 different toolpaths in here. I'm going to go ahead and simulate all the toolpaths, which I can do by selecting the setup and then going to simulate. I'm going to go to comparison here instead of material. So again, in comparison, any green surface is finished, any blue surface has remaining stock, and anything in the red we've overcut. So in this case, you can see the headstock is buried somewhere inside the stock, but the top of the neck, where the fretboard would be glued on, has not been, it is already finished because we're starting with a 3/4 inch piece of stock, but the truss rod slot has to be cut. Okay, so let's go ahead and I think looks like the first operation are the tuner pegs. So that's going all the way down through. Now this is an outline of the headstock, which is basically just cut down to where we're going to reduce this headstock down to. Then a roughing operation, which is cutting out just the headstock material almost down to where it should be, but leaving a little bit so we can get it in a finished toolpath. This roughing operation is also going to show a step up, a transition to the top of the neck. Right here you can see the steps coming in. Now it's going to the next toolpath, which is actually a parallel finishing toolpath with a ball nose. And now it is finishing. I'm not sure. That actually isn't a ball nose, but I'll go into why we can get away using a flat end mill here when we analyze that toolpath. But you can see it's now doing the transition step up to the top of the neck. Notice it's not dipping down to the tuner holes, and there's a little trick to prevent that, which I'll go over. Let's pick up speed a little bit here. Finish the smoothing operation on the headstock. And now with a smaller bit, I should slow this down a little bit. It's very quickly, very quickly doing our truss rod slot. And there's actually two. We're doing a truss rod pocket operation and then doing a finishing operation using a contour. And I'll go into why there's two appear to be duplicate toolpaths here. Okay, so let's start by analyzing our first toolpath, which is the tuner holes. So this is pretty simple. This is going to be a boring toolpath, a 2D bore. And basically, all we have to do is pick these holes. Now, it looks like we don't have any holes here, and actually, that's the trick I used so that when we're finishing the top of the headstock, the tool will not dip down into these holes. I actually patched these surfaces, and they're separate bodies. So I'm going to go into the model, and let's see, in the neck, if I open that up, we've got some extra bodies here that are all surface bodies. So for the time being, I'm going to hide those 6, and now our tuner holes open back up again. So backing up here, our selection of a tool was a 1/4" flat end mill to fit inside this hole. I think it's a 10mm hole. Let me check it. See what that is. That is 0.394, which I think is 10mm. The visibility came back here of our patched hole tops, so I'm going to hide that again. Okay, back in our toolpaths, going back to our tuner holes. Okay, so you can see the boring operation is spiraling down into the hole. So I've got a 1/4" bit here. I've got a 40" per minute cutting rate. If we go to the geometry, remember this select same diameter. So basically all you have to do is select one face, turn this on, and all 6 of them are selected. Okay, so if we go to our heights, I've actually got the stock top selected for our height. Now, you might think, well, why don't we just select this reduced surface on our headstock? That hasn't been cut yet. So we literally do want our stock top to start our cut, the top height. And then the bottom is the stock bottom, and we went beyond 5 thousandths. Same thing we did when cutting the index holes, just to make sure we get a clean cut on the back side. Okay, let's see, our clearance height. Looks like it's an issue here. Let's see if I do an okay. Yeah. Okay, clearance height, face height reference. Let's just set this. I don't know how this got changed, but I'm going to set this to retract height, an offset of 1/4", which is what it normally is. Okay, passes. I didn't do anything in this boring operation. And so that's it. You can see the tool path spiraling down there. Let's go ahead and simulate that. And it's probably going a little fast here, but we can see the last 2. And if we turn this on its side, and we play that again, we should be able to see the bit go just a little bit through, which we're seeing. Okay, so I'm going to close that. So once that's done, we should see green in those holes. And I think we did. Let me just confirm that. We'll run this simulation one more time. So we're seeing something interesting here. We're seeing green inside the hole a little bit down, but this blue ring here is going to get cut out when we reduce the depth of the headstock. So that's why it's showing blue and green. If we looked at it from below, we'd see these green holes. Okay, so that's our first toolpath on the neck top. Let's go to the second one, and this is a headstock roughing. By the way, if you don't see everything that's in this browser, you can just pull this sideways until nothing's getting truncated here. So this is my headstock outline. This is not the roughing. So let's simulate that alone and then go ahead and analyze it. So here's the simulation. So it's taking a 3/8 inch flat end mill and it's cutting around the profile of the headstock, but it's still leaving some material on the sides, so it's not doing the finished cut here. The purpose of this is we're giving the next toolpath room to operate when it reduces this headstock top down so that it won't collide with our stock when it gets towards the edge here. So pretty simple toolpath. Let's look at that. Double click to edit it. So we're using a 3/8 inch flat end mill. This is at 80 inches per minute. So let's take a look at the geometry. Basically, we want to cut around the perimeter of this headstock and stop before we start with the neck. So if we look at geometry, you can see that it's an open contour. It goes around and it stops right here at the start of the flat portion of the neck. Okay, so let's see how that was selected. We want selected contours here. I'm going to delete the chain. Now if I just click here, that's a good start. If I click here, it's going around the whole neck, which is not what I want. So I'm going to delete that chain. So what I did was I clicked here, and then I alt-clicked on it. And you get this little thing where you can kind of build your own contour. We want an open contour, so that's selected. And now I want to click on all of these sections that I want a continuous contour for. And you can see they turn a light blue, a little bit difficult to see, but let me try to select that one again. Okay, that's selected, and that's selected. Okay, so now that all of those continuous contours are selected, and keep in mind it's open because we don't want the bit to come across and slice our neck up, I'm going to press this plus button, which accepts the contour. And now you can see that it matches the one that I deleted previously. Our line is on the outside boundary, so that's good. So now let's look at our heights. So basically the bottom of that, basically this cutaway in the headstock is where I want to take that outside contour down to. So we're starting at stock top and we're going down to a selection, and the selection is this face. Okay, now since this is a roughing pass, let's see, did I leave any extra? I did leave 20 thousandths radially on the walls, basically. And let's just go ahead and do an OK and see what that toolpath does. So since this is a contour, this is cutting with the full width of this bit. I mean, it's a 3/8 inch bit, but still I don't want to cut more than half the diameter of that bit in any one pass. So you can see there was a couple passes there. Let's go in and take a look at that toolpath and see how that was done. I just did a multiple depths here, and I set this to I guess that is half of 3/8. So that's, I believe that's 3/16, 0.1875. So that's how the multiple depths was derived. And now that we look at the toolpath, we can see that we do have multiple depths here. And it's also ramping down. So let's play that again with that in mind. And you can see the tool's getting a little deeper as it ramps down. Stops right there near the side of the neck. Let me pick up speed a little bit here. And it's traveling in 2 directions, which is another check mark inside these dialog boxes. Okay, so that's done. Basically, again, the reason for that is now we have kind of a safe area when we're hogging out all this material in the headstock, where the tool, when it gets to the edge, it's not going to collide with the stock. So the next thing we're going to do is that actual roughing out of this area. So let's simulate that. And you can kind of see what it's going to do is it's going to bore down and then in a circular motion do an adaptive clearing. So let's play that a little fast here. So you can see it's cutting with the side of the bit, which is an adaptive clearing. And it's leaving a little bit of stock for the finishing operation, but hogging out most of this headstock. And then once it finishes, it's going to actually do this step-up transition to the neck right there. So that's the end of the roughing toolpath. So let's edit it, take a look at the settings in there. We're starting with a 3/8" flat end mill. The geometry is the same machining boundary, but it's a closed profile now. So I did the same thing to make this, a very similar thing. Let me turn this off and do it again. So we're going to start with this. Just clicking here, even clicking here is not going to add, it's going to add too much to that machining boundary. So we're going to click here and then hold down Alt and click on the red toolpath. This time we want a closed contour. So we've got a section of it selected. I'm going to click here. Did I get it? There it is. Right here, we're going to come across. And there should be, I think, 3 pieces here to get. Yep, got it. Very difficult to see this. I wish they would make this a little bit thicker, this blue selection. But I think we got it. So we're going to hit plus to accept it. And then you can see we've got this kind of greenish contour that basically defines exactly what we want to cut here. So I think that's all we need to do in geometry. The heights. So we're going to cut from our stock top down to this selection, this face, the same way we did in the perimeter cut that we did previously. Now let's see, since this is a roughing operation, we do want to leave on the floor our axial stock to leave 20 thousandths. And that's basically all I did there. Okay, so we'll simulate it one last time. So our 3/8" end mill is spiraling down, helixing down, then doing its side cutting, and you can see it has no problem going beyond the geometry because it's been cut away. And so that is our roughing operation. Okay, so next up we're going to go to our finish headstock operation. Now, I originally said that this was a ball end mill, but it's actually an end mill. So we picked it's the same tool we've been using, this 3/8" flat. The reason we can get away with this on a finishing operation is we are going to use a parallel toolpath and step straight up on this transition. And when we do this, the end mill's sort of acting like a ball end. So with a straight parallel, and we're perpendicular to this line here, we can get away with that. So we've got our tool selected. Since this isn't cutting much, I'm going to go at 140 inches per minute on this finishing operation. Let me pull this out a little bit. Let's go to geometry. Same thing here. Selected the machining boundary. I'm not going to go into that again, but same as we did it in the roughing operation. Now, this is something that I learned in somebody else's video recently. This defaults to 0. Okay. Now, I'm going to go ahead and show you the problem with this toolpath. And I didn't see the problem until I actually cut this yesterday, and the bit just dove straight down through this stock. You can see these two lines here. Very troubling. I think it actually moved the bit inside the collet a little bit too, and kind of screwed up the finishing of this top. So when I simulate this, watch this. So here's our finished toolpath. And you're going to see the problem here in a second, right over here in this area. You see the holes that it cut all the way through the stock, and it just plunged down there really quickly. And the other weird thing is Fusion's not reporting a collision with stock. That is certainly a rapid collision with stock. So it's as if Fusion didn't know that it was doing that on the toolpath. There is a fix for that, and I will show you that. So I'm not going to watch this finish. So we can see the problem right here. See how it's dipping just straight down through the entire stock. Okay, so I don't totally understand this, but I can show you how to fix it. In passes, there is a setting called tolerance that's set to 0.4 thousandths, 0.0004 inches, tiny amount. Something about Fusion will translate the model into an STL model, which is like a triangular mesh type model. And this is the tolerance that it uses to do that. And I guess it gets screwed up sometimes, just creating, extra crap on your toolpath. So if you go into geometry and set this additional offset to the negative value of whatever this is, so if you put in negative 0.0004 right here, and let's go ahead and generate the toolpath again. Magically, that big dive down is gone. It's just eliminated. I don't know why Fusion doesn't do that automatically. You would think it would. But anyway, so that solves the problem. Let's look at one other thing here. By default, this is probably turned off, this contact point boundary. So let's go ahead and show the toolpath without that. And let's see if this bit is getting up all the way onto the top of the neck with its transition here. So I'll speed it up a little bit. It actually is doing that. So if this wasn't finished all the way up, generally this setting will fix that, which will allow, you know what? I guess you don't need it with the flat end mill, but with a ball nose bit, you definitely would need this turned on. So I'm going to turn that off because I don't need it with this mill. Okay, so heights. Pretty much the same as what we did on the previous. We've got our stock top. This is interesting. We really don't have to go from the stock top, but I think Fusion's kind of figuring out, where to start here. And same thing with our model bottom. We're obviously not cutting to the model bottom, but Fusion's doing the right thing. Passes, we don't need multiple depths because this is a finishing pass and there's very little to cut. But in direction, we are going in both ways here. Okay, so let's just simulate this entire finishing toolpath. Okay, so there's actually a problem here. It's kind of hard to see in the simulation. But if we get out of the simulation, we can zoom in on the toolpaths, and you can see how the bit wants to dive down. When it gets to the very middle of the hole, it can actually get that 3/8" bit down into the hole. So it's going to do that and probably scar the outside of the hole while doing it, and certainly mess up this nice, clean, parallel toolpath that it's doing. So how do we prevent that? That's where these bodies come in. So if we go to our headstock finishing, and in our geometry, go down to model, and we want to add some surfaces to the model. So these are the surfaces that we want to add, and I'll show you how I created those. Back in the design side, if we go to, let's see, we're in the neck stock right now. Let's go to the neck, activate that, and I've already made these bodies, but I'll show you how I did it. Oops, I'm in body. Okay, here's the neck. These bodies right here, basically, all I did was I came into the surface environment and did a patch. So I've created a body. Let me delete one of these guys. I'll delete this one. Okay. So now I've got a hole. Looks like I deleted them all for some reason. Oh, I guess they're hidden. Okay. Unhide. So I've got 5 of these. I'll show you how I made one of these. So here's the hole, and I'm in surface. I go to patch, and then just click here, and that created a new body, and it's a surface body, not a solid body. So it's just a planar surface right there. But that's enough to stop the bit from going in there. So we've got our 6 bodies, which are, these patches. So let's go back to the manufacturing environment. So in our, let me collapse the model down here. So we are in our neck top, and we are doing our finish operation on the headstock. And if we go into geometry, in model, we can actually add these surfaces. So let's open up our model again. We can actually add these surfaces. So I'm clicking and shift clicking here. See how I have 6 bodies here in the dialog box? These are now part of the model. So now that they are, and that toolpath gets regenerated, I think when we zoom in here, we no longer see the dip into the hole because the hole has been patched. Okay, so let's simulate again, make sure we've got everything now. Okay, so that's our finished headstock. This is just the tail of our toolpath, this blue, but we can see underlying that is all green. So our headstock is finished. So let's close that toolpath. So we have 2 more toolpaths here. Let me collapse the model down. And we've got a truss rod pocket operation. So let's simulate that. So we've got a 1/8" bit here, and it is basically cutting everything in that pocket. We were using a spoke wheel on this particular Telecaster, and you can see that the bottom of this slot is the same for the double action truss rod, this barrel of the spoke, and this spoke itself. If I go into the model, let me go ahead and turn that on temporarily just so you can see it. Let's see, there's our truss rod right here. Close here. Truss rod. Oh, our components are all hidden in the truss rod. Okay, so that's the spoke and the barrel, and this is our StewMac double action truss rod. So I'm going to hide that. Okay, So collapsing the model down again and looking at our toolpath here. So nothing fancy here. This is a pocketing toolpath. We've got a 1/8 inch flat end mill. The geometry was really easy to select. I'll select it again. All I did was hover over this surface right here, and it selected the entire thing. Then heights, it went from stock top down to model bottom, but actually we can just say down to selection. No, down to contour. No. Okay, we'll do selection and then we'll actually click on that. So down to this face is where it's going to cut. Passes, we definitely want multiple passes on this 1/8 of an inch bit. So where's that? Let's see. So we have a maximum roughing step down is going to control our passes. So I've got that set to 0.0625. And I think that's all I did. So let's go ahead and click OK. We will simulate this toolpath. And you notice I didn't do any stock to leave. So there's no stock to leave on the sides and no stock to leave on the bottom. My experience, at least with my CNC, that means this truss rod will not fit. It's just too tight when I cut it exactly to spec. And it's not deep enough either. So because this was a multiple pass operation, and you can see there's lots of little passes here. We're just kind of chipping away at it, maybe a 1/16 of an inch at a time. So when we cut this a second time after, I want to cut it twice because I want to test and see, maybe it'll fit if we cut it to spec. But my experience is it's not going to. So now there's another toolpath. This is actually a different toolpath. This is actually a contour. So basically it uses the same geometry here, but it's going to come all the way down with a single pass and then just cut the sidewalls. Okay, so if this wasn't set, let's turn stock to leave off temporarily. And go ahead and simulate. So now, oops, a little too fast. You can see, where's it coming in? Okay, so it's coming in here. And it's ramping down. But as soon as it ramps down, pick up a little speed here, then it starts cutting at full depth. And it's just once around, once it's at full depth, and then it comes back out. So, since that's also set to the same, the same slot, it's not cutting anything. What we want to do is come in here and turn stock to leave into something negative. So here's my stock to leave, and I've got, oh, it reset. That's unfortunate. See if I can remember what it was set to. I wonder if I can undo that. So I'm going to do an undo. And I'm going to double click here, come in. Okay, this is what it was set to. I had stock to leave turned on, radial, which means the walls are negative 0.0025. My experience on my machine anyway is if I overcut something by 5 thousandths, so 0.005, that gives me enough clearance to get the piece in. But if I'm cutting on two sides, which we are here, I want to cut that tolerance in half. So that's why I've got negative 0.0025, half of my 5 thousandths. So basically 2.5 thousandths on each side. And I do my 5 thousandths, the full amount, on the floor because I'm only cutting one surface there. Okay, so that's all that does, is it takes another swipe. And now if we simulate that, we should see that this actually goes red because it's actually cutting beyond the model. But there's so little that it's cutting, I'm not sure we are going to see red. We actually don't. So one thing you could do here, to make sure that the negative is going in the direction you want it to go in, is you could come in here, go to your stock to leave, and I'm just going to add a 1 in front of this and a 1 in front of this, and then we'll come back and we'll get rid of those. Okay, so now when we simulate, we should see red being exposed when we cut the sides. And there we go. We are seeing it. And we should see red on the bottom too. And we do. Okay. All right, so I'm going to undo that. I'm going to do a Control Z. Hopefully that sets things back. We'll simulate one more time. And we shouldn't see any red here, even though we are overcutting a little bit. We're overcutting so little that it's not showing up. So when I run this, it is cutting a little bit, but it still looks like it's green. I bet you if we cranked up our accuracy here, we would see it, but it really slows down the toolpath generation, so I'm not going to do that. But I will take one more swipe at this, go over to our passes, and yeah, that's what we had it set to. Okay, so that is our neck top. Okay, so I'm going to collapse up this setup, and I'm going to activate our neck bottom setup. And now you see that the piece flipped over, which is nice. This is how we're cutting it. You might wonder how you get the piece to flip over. The way I do that is I go up to named views, and let's say our view was this way, which is the same as what we were looking at. All you'd have to do is flip the piece over manually, just orbiting around here. And then what I did was I went right click, I did a new named view, I updated the view, I called it CNC bottom. This is the view from my, the side of the CNC that I stand on. And then when you right click on your setup, you can go to associated name views and pick CNC bottom. So once that's part of your setup, then when you go back and forth between these setups, the part will flip by itself, which is nice. Okay, now you'll notice that I am Z-zeroing off the top of this. The reason I could get away with this, and in other necks that weren't milled down to the exact thickness, you'd have to index off of the bottom here, off of the same spot. But as long as I know that this stock thickness is exact, this surface was not being cut. This one was not being cut. And on this side of the guitar, this was not being cut. Those were all finished by, taking a piece of stock and putting it through a planer and, putting calipers on it and making sure that it's damn close to 3/4 of an inch. So saves a lot of, operations on the CNC. And the planer, I think, my planer anyway, gives me a better finish here. If you were to do something that you wanted to do some thickness planing, say your stock started at 1 inch here, you could surface this and surface this with a planing mill. And then if you were doing that, you probably would want your work coordinate system on the bottom of the stock, which is essentially the same as the top of the neck. So I can get away with kind of cheating here and leave my work coordinate system in the same spot on the top of this stock, and it was on the top of the stock here. I mean, technically it's not the same point, it's on the bottom, but relative to the view, it's in the same spot. Okay, so let's see, I'm going to double click. Here's our setup. Nothing different. We're using the same model, the neck body, and we're using the same stock, which was a stock that we modeled inside the cam component inside the model itself. If I open up the model, You know, we had this cam component, and then I made a neck stock component inside there. So that's where this came from. Okay, so I'm going to cancel out of there, collapse the model down, and let's open up our neck bottom. And you can see we only have 3 toolpaths here. Basically, the only sections we have to deal with are this, 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 and this, and also cutting a perimeter all the way around the outside. So that's what we're going to start with. We're going to start with a profile here. Let me go ahead and run all the toolpaths. And you can see these are essentially finished, not on the CNC. So this is a profile that's going to go all the way around the guitar. And I'm specifically cutting that first because then when we do our roughing operation in this area of the neck, the bit has somewhere to fall into, you know, when it's getting close to the edge. So you can see that it's not cutting green here. It's leaving a little bit of stock, and in one of its finishing passes, it's going to cut down to green. Actually, in its finishing pass, just one of them. All right, let me pick up the speed a little bit here. Oop. Now, another thing you might see here is there's actually tabs that are getting exposed here. Now, the first time that I cut this neck, I was using tape. And what happened was, tape and no tabs. And what happened was, when the bit came around to this section right here, and because this blue area down here is already removed when we did the setup on the other side, I think the headstock was actually vibrating up and down because it had room to move. And it was vibrating so much that I think it came up and it caught the edge of the bit and it actually ripped the tape off, and this came flying up and it got damaged. So the fix, even though it's still taped down the middle, I'm also going to leave tabs here and purposely put them here and on the end here. Big tab down here, and I'll show you how this big tab was created. So that secures this so that once this profile is cut, this headstock isn't going to move. And it still has to be taped down. But it's also attached to the main stock, which is clamped down. So it's kind of a dual approach, but certainly fixes the problem of the part flying off. So, all right, so that's the profile. Let's continue through the next. This is a neck roughing, and you can see it's kind of stepping up towards the middle on both sides. You can see the steps here. I'll speed this up a little bit. It's doing another pass on the roughing. And then this is actually switching to a ball nose and doing the finishing here. And that's it. So then we would have to clean up these tabs, you know, once we're done here. All right, so those are the 3 toolpaths we're going to go over. So let's open up our profile toolpath. I am using a 3/8 inch flat end mill, and I'm going at 70 inches per minute. Since this is a profile, it's using the full width of this bit, so we don't want to push it too hard. So let's see, the geometry, I was able to get a single chain, and I don't think I did it this way. So I could do it this way where, you know, holding down this and using the Alt key and getting a chain all the way around. But I have in the model something else I can use. I've got, if we open up the model, there is a sketch in the model, in the neck. Let's turn our sketches on, go down here. There's a profile right here. So that's very convenient. I can just select that profile, click on that, and that was created by projecting our geometry down to a bottom plane. So that's exactly what I want for the profile cut. I want to turn tabs on, and I want to select the points that I want my tabs in. Okay, so you'd probably notice that there are 3 tabs, and one of them was big. All the tabs generally are the same size, but what I did, if I turn these points off, what I did was I clicked, here and here, and then at the end I clicked these 2 successive points, and this area isn't big enough for the 3/8 inch end mill to get in, so it made this one monster tab, which is good. I specifically want the tab on this curved part of the headstock because that'll be easier to sand down. I'll actually use a pattern bit on the router table. The bearing on the pattern bit will ride right here on this surface. Now, you may notice that these tabs are gigantic in height. The reason they are is because of this side, the headstock being reduced away already. So really the bottom part of these tabs really isn't going to be here. It's just from this surface right here on up. But Fusion is going to put the tabs at the bottom of our profile toolpath. Okay. And we're stuck with the same height, so we've got this height as well. And I guess, you're probably asking, well, why does it go down far on this side? The profile cut actually goes down into the spoil board quite a bit to create room for the roughing and finishing of this section of the neck. So let's take a look at that. So I'm going to simulate this again, and you know what, let's look at it without the simulation. We can see how this went down below by a couple of passes, and we specifically want to cut into that. I've got an extra piece of MDF that I use that's got the holes to mount the stock in, so I'm cutting into this MDF that's actually attached to my real spoil board, so I'm not going that deep into my CNC spoil board. So let's see how that's done. So I'm going to open up the profile, and we've got our 3/8 inch tool. We selected our geometry. So in heights is how it was done. It went from stock top down to stock bottom minus 1/8 of an inch. So 1/8 of an inch cutting into our MDF fixture plate. Passes, I do want roughing passes, and the maximum step over is 1/8 of an inch. So specifically want to step over because we're going to come in with a big ball nose bit and do the finishing, so I want a wide trough here. And we also want multiple step downs. So let's see, where's our step down here? Here's a step over in our passes. Somewhere there's a maximum step down. Oh, okay, here it is, our multiple depths. This is our maximum roughing step down, which is 1/8 of an inch. Okay, so our contour is going to go 1/8 of an inch at a time. Kind of conservative with this big bit, but when you have a part fly off, you generally get conservative. So you can see we're taking multiple horizontal paths and multiple vertical paths. And in the end, let's see if I can back this up a little bit. In the end, it's taking a single finishing pass at full depth and exposing the green. Let me slow that down, do that again. Try to slow it down right before the finishing pass. So it should be coming up next. Nope, not quite. See how it's cutting our tabs. Let's see if this is going to be the finishing pass. So we're at full depth now. And we should see green as it comes around the heel. No, not yet. Okay, here's our final pass right here. No. Let's speed it up a little bit. Still not our final roughing pass. Oh, you know why? Because it's over. Yeah, I didn't realize that it's doing that extra 1/8 of an inch depth. Sorry. Let's see if I can do this again and speed it up. Okay, so now I'm going to start slowing it down a little bit. Okay, there's our final pass. That is our finishing pass. It's at full depth and it's finishing off the side. So that yields a nice finish. Our tabs are down in the heel. This is not going to be exposed anyway. That'll be inside the body. So that's in a good spot. And our gigantic tab here is in a good spot so that we can use a router table to finish that and then do any kind of sanding on a drum sander to finish that off. Okay, so that was our profile. So that's creating an area for the next 2 toolpaths to operate in. So let's collapse the model down and take a look at our last 2 toolpaths. Okay, so the first one here is a neck roughing. We're going to stay with our 3/8 inch flat end mill. Geometry, this is an adaptive, a 3D adaptive toolpath, so it kind of figures out everything it needs to cut. All you need to do is say, okay, stay within this boundary. So that's what this machining boundary is. I use the same sketch, the profile sketch in the neck, to be able to select this perimeter in one shot. Let's see. We have stock contours turned on. If I click on that, that's actually the same chain around the outside. And we have an additional offset of 1/4 of an inch so that I want, well, let me turn that off and we can see what happens. So let's go ahead and generate that. All right, so still generating. Okay, so we are now simulating, oops, not sure what happened there. Let's go back. Okay, here's our neck roughing. Simulate. All right, so let's speed that up and see what we get. So this is our roughing pass. And the problem was, if I didn't tell it to go an additional offset, it really wasn't roughing down very far in the curvature of the neck here. So to fix that, I added an additional offset here of 1/4 of an inch, which seems like a lot, but that got me to, roughed all the way down to the sides. So you can kind of see it here in the toolpath. See how it's coming down here. So we'll simulate that. So the tool is definitely out, working at least somewhat outside the boundary. I don't know if I have it tool on center. Let's take a look at that. Geometry here. I have tool on center of boundary. So if I hover over that, you can see what that means. That's going to allow the tool to go, the center of the tool, to be aligned with this boundary right here. Between that and our extra 1/4 of an inch of additional offset, that allowed us to get the full roughing done. Let's take a look at our heights. Our heights are pretty standard. We went from stock top to model bottom. And let's see. So now we are going to go into our finish pass. So this is a tool change. This is a 3/8 of an inch ball end mill, or ball nose mill. Our geometry, this is a parallel tool path. So let's see, I've got nothing selected in geometry. So basically finish the entire neck, except there's two faces here to avoid. So I went into avoid touch surfaces, make sure this is not checked. That would tell it to touch these surfaces. We want to avoid those surfaces. So I just selected this face and this face because these were pre-finished in our stock. Our heights, let's see, our bottom height, not sure why that's set an extra 1/8 of an inch low in the finish. Oh, I guess that allows the ball nose bit to come down and really finish the edge. Yeah, it does. So let's see. If this was set to what you would think it would be, 0, we're going to see a finishing problem here. Okay, so our roughing toolpath is done. Let's simulate the finish toolpath. And you can see, if we zoom in here, you see some blue areas. So the ball nose bit didn't want to go down beyond the bottom of the model because of what we selected for our heights in our heights tab. So let me stop this, go back into our heights tab, and this was set to, I don't remember what it was set to. I think it was -1, -1/8 of an inch, -0.125. Okay, so now if we simulate this, you can see we're getting all green here. And if we look at it from the side view, right here, let's rewind this. We should be able to see that ball nose bit come through the stock right there. See, it's coming through the stock. And so that's why we cut into the MDF fixture an 1/8 of an inch extra when we did our profile, so that the ball nose wouldn't collide with the MDF fixture. Okay, so I think what we're going to do now is just run our top and bottom tool paths together and make sure that everything in the model is green. Let's take a look at this side. This all looks good. So I'm going to close this. I'll collapse down this setup and this one. And so I'm going to click, shift click here. So we have our top and bottom setups selected. Let me activate the top one. So that got us to this top view. I'm going to simulate, and instead of letting this thing run, I'm just going to go to the next operation, which will show you. Let's open these guys up. So it's on tuner holes right now. If I go to next operation, boom, all the tuner holes are done. And you can see that the holes are actually cut. So if we go to the next operation, this is the headstock roughing. No, this is the headstock outline. This is the outline that we wanted to do before the roughing. This is the roughing, including the transitional rough here. Next operation is our truss rod pocket. No, I'm sorry, the next operation was the headstock finish. So headstock got finished off. Now we're about to do the truss rod. Okay, then now we're going to do the truss rod finish, which is the overcut of the truss rod. Now we're going to do one of the bottom guys. Let's see, is it going here? No. All right, I must have done something wrong there. I guess I didn't select both of these. Okay, so I'll do it really fast. So tuner holes, boom. Headstock outline, done. Headstock roughing, done. Headstock finish operation, done. And then our first truss rod, our second truss rod is done. Now we're about to, you see how the tool is on the other side. I just spun this thing around. We're about to do the profile. So profile is cut, our tabs are in there. Next operation is our neck roughing. And the final operation is our neck finishing. So now at this point, if we orbit around here, we should see green everywhere except for our tabs. And that looks like the case. This is a sketch here that I should have turned off earlier. If I go into the model, let's see, open up the model. And here we do have sketches turned on. Okay. All right. So that is our completed cam of the neck.